So the today, please wait. Hmm. So we are discussing more details about how her virtualization will be achieved. As in last lecture, I said that ki virtualization is a process, right? And by which we can create the logical instances of the physical resources. Please note it down. By virtualization help us to create logical instances of physical resource available, isn't it? So we have a one physical machine available, but on one physical machine I want to install 5 operating system. Normally, by normal way it is not possible, but it is possible with the help of some virtualization. And that machine has to be support virtualization. There are some machine in the market which support the virtualization. Or to achieve the virtualization, so you have to be choose the machine which support us. But if I am the manufacturer, if I want to be achieve the virtualization, what I should do, or what I need to be understood about it. Though I know what is meant by virtualization. Virtualization, yeah, so it is not, as said, it is not easy, but it is not also a difficult to implement it. A computer runs OS that configure to the particular hardware that we know, and running a different OS on the same hardware is not exactly feasible. If you want to make it possible, then what you have to be do it. To tackle this problem, there exists a hypervisor, and we know what is hypervisor. What is the second name of the hypervisor? What is the type of hypervisor? Where it modified the OS and where it not modified the OS. We have seen the type of hypervisor, type of one hypervisor, type 2 hypervisor, and where it is used, and where actually it is to be located when we want to be achieve the virtualization, that we have seen in the last lecture. So what hypervisor does it, that also we have seen how it is to be functioning and what is their role, what it control, and what is the VMM and what is the VM. So VM is a virtual machine manager and VM is a virtual machine. So that we have already discussed. So it acts a bridge between virtual OS and the hardware. Virtual OS means we can be experience it, but it is not physically available on my machine. For example, one OS is available on my machine, but I want to be experience, or I want to be use all 5 OS, different type of OS. You will get and you can be you can be experience the OS, which is all different 5 OS on your machine, but they are physically is not located. But you can be complete your work. You can be do whatever you want to be do with them, but it's available virtually. That instance logically available for you to get your work to be done. So hypervisor is a bridge between the virtual OS and the hardware to enable smooth functioning of the all instances of the OS. Yeah, so please. There are 5 levels of virtualization available, and that most commonly used in industry, like SLA. First layer is a ISA, which is a instruction set architecture level OS. So virtualizer work through an ISA emulation. So here some instruction are there that to be used and modified. This help to run heap of legacy code which was originally written in different hardware configuration. And if you want to enable the hardware like this one, you should know the assembly language or hardware level instruction to be understand. ISA is a machine level. You know the ISA machine, right? So this code run on the virtual machine through the ISA architecture. Binary code might be need additional layers to run, can now be. So these are the machine configuration that we to take into consideration. So ISA help make the hardware agnostic virtual machine. The basic emulation like the things we have I have explained earlier also. Simulation and emulation, what is their difference between them, that right? So you want to check the speed of the your bike. If you want to check the computing power of your machine, you have to be emulate this hardware in the machine, and you have to be check the performance of it. So this is possible with the help of emulation software. So there is a two type of the virtual software, like emulation and simulation, which can be used to analyze the speed or to check the computing power of machine. So that software is called as a emulation software. Through A require interpreter. This is interpret the resource code and convert into the hardware reliable format for processing it. Yeah, just wait 1 minute. So so emulation. This interpret or interpret the source code and convert it to the hardware reliable format for processing. So it is like a hardware, right? It's hardware level. So hardware level abstraction, as the name suggests, this help us to perform the virtualization at hardware level. It uses bare hypervisor which are close to the hardware, right, for its functioning. This level helps to the virtual machine and manage the hardware through the virtualization process. It enables virtualization of each hardware component such as IO device, processor, and memory, all the peripheral. At this level, it can be said. This way, multiple user can use this same hardware with numerous instances. For example, we have one machine, their instance will be numerous means more than one or n number of bits, right? Up to the 1 to n. So at the same time. So IBM machine is available for this hardware virtualization. So the next level is the operating system level. At the operating system level, virtualization node create an abstract layer between the application and the OS. So this layer, right? So it is like isolated container on the physical server and operating system that utilize hardware and software. Each of these container function like the server. And when the number of user is high, no one is willing to be share the hardware. This level of virtualization comes handy, which is actually a control level, right? Here, every user get their own virtual machine with the dedicated hardware resources they want to be used on demand. This way, no conflict arises in that case, and this layer is responsible for this controlling all. So library level, the OS call system call. We know what is system call, lengthy and cumbersome, which is why application of obtain an API user level will be library is there. So most of the APIs, application peripheral interface is provided by system rather than well documented. Hence, library level virtualization to prepare in the such a scenarios as well. So library interfacing virtualization is made possible of the API hooks. This API hooks control the communication link between the system and application. So there are many virtualization tools. You know what is use of Wine and what is use of CUDA have successfully demonstrated technique, which will be you can be download this software vCUDA and Wine. So you might be know the what is Wine. I will be raise this question at the end of the session. We'll tell you what is Wine also. If you know that, anybody can share with me also what is Wine. So application level virtualization come or handy when you wish to be virtualize only application. It does not require any entire program or any environment to be achieved at the application level of virtualization. So only an operating system is application work upon the open process, and it is also known as a process level virtualization. It's generally useful when running a virtual machine with a high level of language. Here is the application site on the top, so you can be use it. So if you want to see the diagrams, right, how it is looks, so a level of virtualization, we can be virtualize your application, you can be virtualize your libraries, you can virtualize operating system, yeah, hardware level virtualization. So if you want to virtual this, will you should be look at this all the type of virtualization. So we just wait 1 minute.
explain operating system visualization.
How practically it will achieve?
Is
Yeah, please wait.
that is very common, especially currently when everything is going to the cloud, meaning that whole lot of things is being done on the local computer on the desktop. Everything is moved to the cloud. You can get word processing, spreadsheet, your files can be stored away in the server. Even application, instead of getting installed in the system, you can just use them right there in the on the internet. So, but this is not what we are talking about here. What we are talking about here is operating system visualization. How do you visualize operating system? So, a little overview. It refers to the use of certain software to allow system hardware to run multiple instances of different operating systems concurrently, allowing you to run different applications requiring different operating systems on one computer system. The operating systems do not interfere with each other while the various applications. This creates illusion that the operating system are running on separate hardware machines. So what are we talking about here? We are saying that you have one single hardware machine, a server, let's say HP ProLine server, and you're able to run 5 operating systems right on the server. Even different versions. So you may have Linux, Ubuntu Linux running, you have Windows XP, you have Windows 7 running, you have Windows 8, you have some Mac also running right there on this single hardware machine. For the applications installed in these operating systems, they tend to see the operating system as if they are running on separate hardware machines. Meanwhile, you just have one single hardware server today. So I create this illustration to explain non-visual and visual operating system. So here is a non-visual. We have the hardware machine, have the kernel, let's say the OS here, and then you install your application, right? That's the normal thing we do. Buy a computer system, okay, a server, install Windows Server 2008. On top of Windows Server 2008, install Microsoft Exchange or install whatever applications you want to use. So the visual system illustration is completely different. So on top of your hardware machine, okay, you have Visual Machine Manager. Okay, so this is a layer on top of the hardware. So on top of the Visual Machine Manager, you have Visual Machine. So you can create instances of the hardwares. Okay, so take a look. Just a minute. So here you can have CPU, memory, and hard disk. Okay, so have CPU, memory, hard disk, CPU, memory, hard disk, CPU, memory, hard disk. Okay, so today's operating system is seeing this visual machine like a physical, as if it's a complete server hardware machine, or it's just visual. So this guy here, the hardware, is divided into visual machines. So I hope it's clear. So in this way, you have application and services installed on different visual machines, and they, interestingly, will not interfere with the operations of the other ones. So we have types of visualization. We have type 0, the hardware-based visualization. Okay, so they are called hypervisors, type 0 hypervisors. They provide for visual machine implementation via firmware and allow the visual machine to run on the core hardware. Okay, they are also referred to as native or bare metal hypervisors. What are we talking about? The hardware-based implementation means you have hardware server, okay, then you install a hypervisor equivalent to the virtual machine layer, and then you now install create virtual machines, instances of of virtual machines on top of the hypervisor. So this hypervisor layer is a very thin layer on top of the hardware. So that is how it works. So you don't have a base operating system. So have the IBM and Oracle implementations of these hypervisors. I think we have the VMware vSpec or VMware ESXi. I think so. ESXi. Sorry, okay, let's leave it. I didn't know exactly, but let's just. Okay, so how the operating system like software solution. Type 1 hypervisors have to be set up on the existing operating system. So if you have a Windows computer and you want to run Linux, Ubuntu Linux on it, just grab a VMware, install this VMware on your Windows, and then install inside this VMware. You can now install or set up instances of virtual machine. So here, the virtual machine, okay, runs on top like an application. So if you open the virtual machine, it's like an application. So inside it, then you have other operating system. That's what we mean by type 1 virtual machine. So what are the benefits of virtualization? The benefits of virtualization, I have outlined 4 of them. Virus on the guest operating system will not affect the host, okay? Of course, you will know that this applies to the type 1, where you have a base operating system and you have operating system set up on a virtual on VMware. So the virus in the guest will not attack, affect the base operating system, and virus in operating systems cannot be transferred to other operating system. They are completely abstracted from each other. And we have the next one, the host operating system, okay, is protected from the guest. So if the guest crashes, the host is intact, nothing happens. Okay? So if one operating system crashes, the other one continues to function. That's great. Then multiple operating systems can be implemented on one physical machine. You don't have to buy a set of servers for you to 8 servers for you to run 8 operating systems. You can just run different operating systems on one physical machine. Then we have cloud computing is made possible through virtualization. Here the CPU, memory, and hard disk are provided like services. So you may simply not even buy a server, just it can provide it from the cloud as a service. And that's where we have software as a service, infrastructure as a service, platform as a service. I'm going to discuss this in my other video. Have challenges of visualization and have high risk of physical fault. So imagine you're running 10 operating system on one physical machine and the other physical machine crashes. Everything goes. High risk of physical fault. Then you have lower performance and non-visual system. Of course, you know that it's going to be slower when you run several operating systems on one machine. Higher cost for you to implement a visual environment. The think of the cost. You have a certain complexity to do the configuration. It's not as easy as running a Windows 7 CD on your computer and just get it working. Then some hardware platforms doesn't support visualization. So this is the most we can take for visualization course. I would like to thank you for viewing. My name is Clayton. I would like you to subscribe to my channel.
22. I think 22. Yeah. Please wait.